So good morning friends, welcome to Water Resources Engineering class. So we are now dealing with the fourth unit, groundwater hydrology. Today's lecture is focused on problems. Very simple, just note down the equation before starting any problem. A tube well taps an artesian aquifer. Artesian means confined aquifer. Find the yield in liters per hour. That is the question. For a drawdown of 3 meters, when the diameter of the well is 20 centimeters and the thickness of the aquifer is 30 meters, assume the coefficient of permeability is 35 meters per day. That is first question. If the diameter of the well is doubled, find the percentage increase in the yield. The other conditions remaining same. Only thing is, instead of 20 centimeter diameter of the well diameter is made to 40 centimeters. Then in that case, how much discharge increase? What is the percentage increase of discharge? Assume radius of influence capital R is 300 in both the cases. So I have written, T is equal to KB, right? So Q1, first part I will take it. First part, what is our first part? You tell me the thing also. Let me take it actually. The radius of the well is equal to how much? 20, right? 20 centimeter is diameter. It is diameter. So what is the radius of the well? It is 10 centimeter. So it is 0.1 meter. That is fine. Next, what is R is equal to 300 meter? He has given already. Then what is T is equal to? T is equal to KB. KB, how much he has given? 35 meters per day. Let us per day. But answer he requires is in hours, liters per hour. So let me do in hours. So 35 meter. What he has given meters per day. So per hour, how much? By 24. This is K. Into B is how much I have given? 30 meters. So if you put it, T will be obtained. So now substitute in that. So 2.72 into T into S by log R by R base 10. This is the fundamental thing. 2.72 as it is. 30 is equal to aquifer thickness. 35 by 24 is nothing but to convert whatever is given meters per day to meters per hour. Right? Into S is how much actually? Right? S is how much? 3 meters he has given actually. So that I have put log base 10 300 by 0.1. So this is the answer. So the first answer is over. Right. Now what we have done, the diameter of the well is doubled. So that means instead of the diameter 20 centimeters, it became 40 centimeters. Then what is the radius actually? The radius is 0.2 meters, 20 centimeters. So rest of the things are same. So what I have done, 2.72 T S divided by this. So 2.72, 30, 35 by 24. This is same, basically drawdown. This is also same. Only this is the change. Now I found out again what is Q2. So Q2 is obtained, Q1 is obtained. So what is the percentage increase? Q2 minus Q1 divided by Q1 into 100. So it is 9.45. Excellent question, I am telling you. Right? So only one equation you can do any problem in this confined aquifer. Same. Calculate the discharge from a tube well of 20 centimeter diameter penetrating fully into a confined aquifer of 20 meter thick and having permeability of 40 meters per day. The drawdown in the well is 3 meters and zero drawdown at 300 meters from the well. If the diameter of the well is doubled, find the percentage increase in the yield. The other conditions remains the same. So now confined aquifer, same equation, same actually. B is known, K is known, R is given. So base S is given, capital R is given. What is find Q? So this is what I have found. So Q1 is equal to C. Any doubt is there? Q2 is equal to, instead of 0.1 here, this is 0.2 here. So Q2 is here. Percentage increase Q2 minus Q1 divided by Q1 into 100. This is 9.48. Very simple thing actually. Next, a tube well of 300 mm diameter penetrates fully a confined aquifer. The length of the strainer is 25 meters. Calculate the yield from the well under a drawdown of 4 meters. The coefficient of permeability of aquifer is equal to 50 meters per day. Assume radius of circle of influence is equal to 200 meters. So what is given actually? K is given, B is given, S is given, R is given actually, then capital R is given. The equation is 2.72 KBS divided by log R by R base 10. Same thing I have put, answer direct straight. A tube well fully penetrates a confined aquifer of thickness 30 meters and coefficient of permeability is this much. Determine the radius of the well if the yield required is Q. So Q is given and asked what is the thing he has asked actually? Radius of well. This is the question. Here one more point also I did not mention to you. Use the equation to determine the radius of a circle of influence. I have mentioned this equation actually when I was dealing with the unconfined aquifer. So this is one of the important things you should know. R is equal to 3000 S root K. S is the drawdown, K is the permeability value. So if you know this, you can find out what is R also. So B is given, K is given, Q is given, S is given. So first find R. So that's what I have done. How I have done also, let me check it up. 38 meters per day, this is given actually. When 38 meters per day is given, 38 meters basically day, 24 hours, hours to minutes, seconds. So this is what we got. Then R is equal to the same thing I have put it here. Then R is obtained. Q is equal to whatever Q is there actually if you see 40 liters per second. 40 by 1000 meter cube per second. That's what I have done. Then I substituted in this and got what is small r is equal to. A well penetrates fully at 10 meter thick water bearing stratum of medium sand and coefficient of permeability 0.004 meters per second. The well radius is 100 meters and is to be worked out under a drawdown of 4 meters at the well face. Calculate the discharge from the well. What will be the percentage increase in discharge if radius of the well is doubled? Take R is equal to 300 meters. Again, anything is equation is fixed first. B is given, K is given, R is given, S is given, capital R is given, find Q. Equation directly I substituted. This is the answer actually. Now this is well is what will be the percentage increase if the radius of the well is doubled. So radius is doubled actually. Then what is the percentage increase in discharge. So questions are very similar, same questions. Equation is only one equation actually for the confined aquifer. Right? Some small multiple choice questions also you can take. Darcy's law is valid for which flow, gentlemen? Laminar flow. The discharge through the porous media according to Darcy's law is proportional to what? Hydraulic gradient. The governing assumption in deriving the radial flow towards a well is flow is turbulent, no. Flow is horizontal and laminar, correct. Flow is vertical, no. Flow is compressible, no. The discharge equation for steady radial flow thing is, now you tell me what is Q is equal to 2.72 into KB, that is what is also called as T into S divided by log base 10 R by R. R is equal to 2.72 KB into H minus H divided by log base 10 R by R. That's all. In a confined aquifer, transmissibility is equal to KB. The drawdown curve around the well in a confined aquifer is known as cone of depression. The governing equation for steady radial flow in a confined aquifer is Dupit-Thiem equation. In the Thiem equation for steady flow, radial flow in a confined aquifer, discharge is proportional to the difference, that is what, H minus H, and right logarithmic ratio of the radii, both are there. This is no basically, so that's why this is the answer. And Darcy's law states that the discharge is proportional to what? Please tell me. Hydraulic gradient. The hydraulic gradient is defined as it is nothing but head loss per unit length. In confined aquifers, water is stored and released due to what? It is compression of aquifer and expansion of water. Then transmissibility is the product of hydraulic gradient and aquifer thickness. The radial flow equation is based on which assumption? Dupit assumption. The shape of drawdown curve around the pumping well is also called as cone of depression. The term H1 minus H2 in theme equation represents actually the drawdown in the two observation wells. The Dupit assumptions neglect the component. Which component of flow? Vertical component, because vertical component is not considered. In confined aquifer, the storage coefficient, excellent question, it will vary between 10 to the power of -3 to 10 to the power of -5. And last, the discharge from a confined aquifer confined aquifer well is calculated using the Dupit theme equation. State Darcy's law, define transmissibility. What is Dupit theme equation used for? Mention one assumption for radial flow intervals. Define hydraulic gradient. What is meant by cone of depression? In confined aquifers, what causes release of water when pressure drops? In confined aquifers, what causes release of water when pressure drops actually? Write the equation of steady flow into a well in confined aquifers. Which parameter differentiates confined aquifers from unconfined aquifers in terms of the storage? Why is Darcy's law not valid for turbulent flow? Anybody? Why is not Darcy's law is not valid for turbulent flow actually? Main reason is for turbulent flow head loss is actually what you call it as non-linear. But whereas what we have considered is head loss is linear. And that is what fundamental thing is actually. Then Darcy's law, discharge through porous media is proportional to hydraulic gradient and area of crossing. Transmissibility is often to transmit water across the entire saturated thickness, which is equal to Kb. The Dupit theme equation is used to calculate discharge. Okay, flow lines are horizontal and equipotential lines are vertical. Hydraulic gradient is change in head per unit length of flow. What is hydraulic gradient? Cone of depression is the inverted cone shaped depression formed in water. Yeah, elastic storage, compressibility of an aquifer. This, what is that actually? Seventh. In confined aquifer, what causes release of water when pressure drops actually? When pressure drops, this is compressibility of aquifer and water are responsible for pushing the water out. The equation already you know. Then what is the ninth question actually? Which parameter differentiates confined aquifers from unconfined aquifers in terms of storage? That is nothing but storage coefficient or storativity. So these are the small just recollection of what you have studied in the confined aquifers. With this actually I thank you all basically for your patient listening, right? And most of the information that which I have presented to you are basically either from the textbooks that they have given or from the reference books. So mainly always kindly go through the textbooks also for the more content in this regard. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.